Today you will be dividing polynomials using synthetic division. So if you look at your notes, you have this box about synthetic division. Okay, so it is essentially you are going to use the following pattern. So the first thing you'll do is you'll take whatever you're dividing by and you'll solve for x. Okay, so in this case, x equals k. I'm going to put that k in that little box. Okay, so essentially what you're going to do next is you're going to drop down your leading coefficients as you see here. Okay, you're going to drop down that first coefficient a and you're going to multiply it by k. That's how we get this ka. And then you will add b and ka together and then follow the same process. Okay, so notice the top. These are the coefficients of the dividend, meaning the polynomial in the house. And notice the vertical pattern is adding terms and the diagonal pattern is the multiplying by k. Now synthetic division is important because it only works when you're dividing by a linear factor. If you're dividing by an x squared or x cubed, you cannot do synthetic division. Let's look at an example. Okay, so the first thing that we will notice here is we're going to take this x minus 2, set it equal to 0, and solve for x. Okay, and note that we do get x equals 2. So I'm going to put the 2 in a box, like so. Now, remember, I need more space. Remember, just like with long division, I have to have placeholders for missing terms. So if we look at what we are dividing, notice we're missing an x squared. So for me, sometimes it helps if I write out the polynomial with all terms. So notice we have a degree of 3, degree of 2, degree of 1 in a constant. Okay, so I want it to go backwards by power. The next thing we'll do is we're going to drop down the leading coefficients. The leading coefficient of x cubed is 1. 1. The leading coefficient of x squared is 0. The leading coefficient of x is negative 7. And the leading coefficient of the constant is negative 6. Okay. And the next thing we'll do is we'll drop down that first term, 1. I'm going to take 1 times 2 and put it underneath the 0. Then I'm going to add down. 0 plus 2 is 2. We're going to follow that same process. Now I'm going to take 2 times 2, which is 4. Add down. Negative 3. And then we'll do it again. Negative 3 times 2 is negative 6. Okay, and this gives me a remainder of negative 12. Okay, so recall what we did last time. If I take an x cubed and I divide by an x to the first, well, my new coefficients go down by a power. So this is actually x squared plus 2x minus 3, and then plus our remainder, negative 12, over what we divided by x minus 2. And this is your final answer. And that's it. So notice we're going to look at another example, and we're going to use synthetic division to simplify. So if we look at our example, the first thing that I would do is I would see if I'm missing any placeholders. See, we have a cubed, a squared, an x to the first, and a constant. And notice in what we're dividing by, we also have no missing terms. So we're good to set up our problem. Remember, we're going to think in our minds here. X plus 2 equals 0. And we'll get x equals negative 2. Okay, that's what's going to go in my box for synthetic division. Okay, so now we're going to drop down our coefficients. So we have a 1, a negative 14, a 51, and a negative 54. Okay, so remember the next step is to drop down that first term, 1. And I'm going to take the 1 times the negative 2. And now we're going to add together. That is negative 16. So next thing we'll do is we'll take the negative 16 times the negative 2, which in this case is 32. Okay, and then we're going to add together. This ends up being what, 83? Okay, so next thing we'll do is we'll take the 83 times negative 2. 83 times negative 2 is a negative 166. And then we'll add these together. And this is my remainder, negative 220. Okay, so all that's left for us to do is to write our final answer. So remember, if I take an x cubed and I divide by an x to the first, that means the power of x for my first term is squared. So we'll have x squared minus 16x plus 83, and then we have our remainder, negative 220 over what we divided by, x plus 2. And that's it. The end. I want you to take about a minute and try the example you tried. Hopefully you found your answer to be x squared minus 4x plus 2. Remember, if there's no remainder, that's okay. The next thing we'll look at is the remainder theorem. Okay, so the remainder theorem, if we have a polynomial function is divided by x minus k, the remainder is r equals my function evaluated at k. So on your upcoming assessments, you'll have a question that says use the remainder theorem to evaluate the function. Essentially, all you're going to do is use synthetic division. So if we look at our next example, notice it says we're going to use the remainder theorem to evaluate our function when x equals 5. Okay, so because x is already solved for, I'm just going to put 5 in my box, and then I'm going to ask myself, do I have any missing terms? And the answer to that question is no. So I'm going to drop down those coefficients. And then we do synthetic division. So we'll drop down the 4. 4 times 5 is 20. Negative 10 plus 20 is 10. 10 times 5 is 50. And then 50 minus 21 is 29. Okay. And guess what? That means our function evaluated at 5 is 29. Now think to yourself, how can you verify this that we actually did this right? Well, what you could do is you could replace the x's with 5 and simplify, and you should get 29 as well. But remember, on a test, if it says to use this remainder theorem, you have to use that method to figure out the function. Okay, now I want you to try the example you tried. Hopefully you found your function evaluated at 3 is 182 using that synthetic division. The last thing we need to talk about for this section is the factor theorem. Okay, so a polynomial f of x has a factor x minus k if and only if my function evaluated at k is 0. Okay, so we're going to use the factor theorem to verify whether or not something is a factor. If I have a 0 remainder, then that means I can say that x minus k is a factor of the polynomial. So if we look at our next example, notice it says we're going to show that x plus 2 and x minus 1 are factors of our polynomial. The first thing that I would do is I would set up synthetic division for negative 2. So I know negative 2, or x plus 2. Negative 2 will go in our box, and we're going to look to see if we're missing any placeholders here. Our powers go 3, 2, 1, 0, so we're good there. We're going to drop down those coefficients, 2, 1, negative 5, and 2, and do our synthetic division. 2 times negative 2 is negative 4, 1 minus 4 is negative 3, negative 3 times negative 2 is 6, negative 5 plus 6 is 1, 1 times negative 2 is negative 2. And because we have a remainder of 0, we can say that x plus 2 is a factor. Okay, we're going to do the exact same thing for x minus 1. Okay, if I have x minus 1, that means 1 goes into our box, and we're going to drop down our coefficients. That looks like an 8. And we're going to follow the exact same process. Drop down the 2. 2 times 1 is 2. 1 plus 2 is 3. 3 times 1 is 3. Negative 5 plus 3 is negative 2. And negative 2 times 1 is negative 2. Notice it worked again. So we can also say that x minus 1 is a factor of f of x. Okay, and that's it. That's all you got to do. Okay, so notice that you're going to do an example you try. Take a second and try it. Hopefully that you found that x plus 2 is indeed a factor of the polynomial x cubed plus 4x squared plus x minus 6. And you are officially ready to work on the practice.